All right, welcome everyone to the 2019 Accelerate State of DevOps Report webinar. That's a mouthful, but this is going to be an exciting webinar. Really excited to be here with Jez Humble, and he's going to walk us through some of these really exciting results that they've been seeing through their research. Welcome on, Jez.
Thanks very much for having me.
Absolutely, and I'm Ben Newton. I'm from Sumo Logic. And always been excited to be partnering with DORA and now with Google on this. We're always excited about what you guys are doing. And just a couple of housekeeping items before I hand it off to Jez to wow and dazzle us with their results. We have a Q&A functionality that you'll be able to use as you go. I just encourage you as you're hearing Jez talk about things, if things come to mind and you like to ask a question, just go ahead and put it in. And we'll get to that when we can. And you guys also submitted some questions when you registered, and we have those as well. So if Jez doesn't answer those, we'll actually take a look at those as well. But with that, I think we can go ahead and get started. So Jez, take it away.
Great, thanks so much, Ben. So what we're going to go through over the next 20 minutes, the very first part of the webinar, is some key findings. The State of DevOps report for 2019 is huge. It's over 80 pages. There is so much stuff in it, we can't possibly get through it in the next 20 minutes. So if you want to see the whole thing, go to cloud.google.com/DevOps, and there you can find the State of DevOps report. You can find all the previous year's State of DevOps reports and lots of detail on the capabilities that we're going to talk about and how to implement them, and loads of great resources there. So we're going to talk about some stats, some benchmarks. We're going to talk about how to get better. We're going to talk about productivity and culture, and then we're going to hand it over to Ben. So over the last 6 years, we've been gathering tons of information in this research program. So I'm CTO of DevOps Research and Assessment. That we're now part of Google, so I now work for Google. The principal researcher of this report is Dr. Nicole Forsgren. She was CEO of Google, now works on research and strategy at Google. So we've been doing this for 6 years now. We've gathered tens of thousands of data points from thousands of companies worldwide of all different kinds. And this year we've got some really interesting stuff. So the first thing is, how do you measure software delivery performance? How do you know how well you're doing at delivering software? Well, over the last 6 years, we've gathered 4 key metrics which have consistently been shown to be statistically valid and reliable, which means they're measuring something real. And there's 4 key metrics that we look at as part of that. Firstly, 2 metrics that represent throughput or speed or tempo, which is lead time from checking in code to having that code live in production or released to users, and then deployment frequency, which is how frequently you're actually releasing to users. And then 2 stability metrics: change fail rate, which is when you push a change out to production, what proportion of the time do you have to remediate in some way? And then the final stability metric is time to restore. So again, if you have some kind of incident, how long does it take you to restore service? How long does it take you to remediate? So 2 throughput tempo metrics, 2 stability metrics. What we find is that high performers do better at both, and low performers do worse at both, speed and stability. So we're not actually trading off going faster for breaking things. What we find is the high performers do better at going fast and at creating stability. Last year, we looked at availability, which isn't applicable in every context. It's only applicable for hosted systems. But what we find again is that high performance on speed and stability also do better at availability as well. Speed and stability support each other. It forms a virtuous cycle. When we look at the proportions of people who are high, medium, low performers, every year we do something called cluster analysis, which takes all our survey responses and breaks them up into groups where the members of the group are more like themselves, each other, than they are like the members of other groups. And it normally breaks into 3 or 4 groups. Last year, we ended up with these 4 groups: 7% elite performers, 48% high performers, 37% medium performers, and 15% low performers. This year, when we did that cluster analysis, it again split into 4 groups, but the proportions are a bit different. We're seeing more elite performers, which means the industry is continuing to improve. The low performers go down a bit, and then the medium performing group gets somewhat bigger. What we think is happening here, and we don't know, because when you're doing this kind of statistical analysis, big data, you never know why something's happening. You only know that it's happening. So what we think is happening, our hypothesis, is that people treat change as a project. They start with improvement work, and then they're done, and they're like, okay, we're done with getting better, back to business as usual. What happens when you do that is you don't stay the same because the rest of the industry is improving. You gradually slide in performance relative to the rest of the industry. So that's what we think is happening here. And we're seeing the elite performing group continuing to get bigger because people continue, high performers continue to improve as part of their daily work. So the other thing to note about this is that we see elite performers in every industry, every size of organization. So you don't have to be a tiny startup to be an elite performer. We see elite performing teams, even within large, highly regulated enterprises. And we see low performers, even in startups. Anyone can do this stuff. We do statistical analysis every year to validate that that continues to be true. In terms of the actual numbers, what we see is that elite performers are deploying on demand multiple times per day. It takes them less than an hour to get changes from checked into version, less than 1 day to get changes from checked into version control into production. They can restore service in the event of an incident in less than an hour, and their change fail rate is really low, 0 to 15%. On the other end of the spectrum, we look at the low performers. They're deploying between once a month and once every 6 months, and that's their lead time for changes as well. And those two things are coupled because they're doing these long release cycles and releasing everything in one big bang release. So the lead time becomes coupled to the deployment frequency. We see quite long time to restore service of between a week and a month, which seems long. What we think is happening here is that it just can take a really long time to restore, particularly in the event of things like security problems, where you might have the service kind of up and running again, but you're still finding problems and remediating behind the scenes and doing data fixes and stuff like that. That can take quite a long time in complex systems, and much higher change fail rates as well. So again, elite performers doing better at speed and stability, low performers doing worse at speed and stability. In terms of an actual numerical comparison between the two, if you crunch the numbers, what you find is that when you compare the elite performers to the low performers, elite performers are deploying 208 times more frequently, 106 times faster lead time from commit to deploy, 2,604 times faster in terms of time to restore from incidents, and a 7 times lower change failure rate. So that's, I mean, these are numbers, they're big numbers. That's the point. There's a big gap between elite and low performers. So, why do you actually care about this? Well, you know, we do tech because it's fun, but also we do tech because it hopefully makes a difference. And what we found every year for the last 6 years is that elite performers are twice as likely to meet or exceed their organizational performance goals as low performers. So doing this stuff matters to your company. What we're looking at here is commercial goals like profitability, market share, and productivity, and also non-commercial goals like quality and quantity of the products and services you deliver, customer satisfaction, your ability to meet your mission goals. So things that matter in every kind of organization. Again, our highest performing group, the elite performers, are twice as likely to meet or exceed these goals than low performers. So this stuff actually matters and makes a difference. So if you're not in the elite performing group, if you're in a low performing group or medium performing group, you're probably wondering, how do we get better? So most of the bulk of our research program is focused on that. How do we actually improve? This year we have 2 models. We've got a model that focuses on software delivery and operational performance and organizational performance on the left here. And then this year we have a whole new research model that's focused on productivity, which we'll talk about a little bit later. So what impacts these outcomes that we want to achieve? Well, culture, which we'll talk about at the end, impacts both your software delivery and organizational performance, and it impacts productivity. Then things like change management, how you do change management, implementing the cloud correctly, technical practices, disaster recovery testing. These are all things that impact software delivery performance. And some of these things are new this year, like disaster recovery testing. We're looking at change management in some depth. And then a little bit later on, we'll talk about how to improve productivity, again, through a more safe culture by creating tool chains that actually help you do your job and are easy to use, by making it easy to find information about how to do your job inside and outside the company, and by reducing technical debt. So we're going to do a little bit of a deeper dive on how to improve software delivery and operational performance. So this is our model. What you can see here is each of these boxes on the left-hand side is a capability. It's something that you can do in your job. And these things impact software delivery and operational performance. That's that yellow box towards the right. And you can see how the various different capabilities we talk about, basically they have lines and arrows, so that indicating that improving that capability improves that outcome. And then on the right, you can see organizational performance, that key outcome, which is impacted by both software delivery performance and by culture. Improving culture doesn't just improve your software delivery performance, it also improves those organizational goals that we discussed earlier, those commercial and non-commercial organization goals. So how do you get better at software delivery performance? How do you improve your culture? You implement these capabilities. So there's a bunch of technical capabilities that we call continuous delivery. That's things like continuous integration, deployment automation, trunk-based development, monitoring, loosely coupled architecture, and code maintainability, which we'll talk about a bit later. Implementing disaster recovery testing programs that actually test your disaster recovery capability in production. That impacts, that positively impacts availability. And then some things that we don't have time to talk about now, but are very important: creating a change process that is lightweight, which is to say that change approval happens based on approval within your team rather than external approval by a change advisory board. And also clear change process, which means knowing what your change process is and being confident that you can take changes and get them through that code change process or change process successfully. So that impacts not just your performance, but also it improves your culture and it reduces burnout. So all these things help. We're just going to do a deep dive on one technical practice here, and that is using the cloud. What we find is that cloud makes a huge difference, but only if you do it right. What do we mean by doing it right? Well, NIST, the US federal agency, the National Institute for Standards and Technology, has this nice short paper where they define what it means to have a cloud. 5 essential characteristics. Number 1, on-demand self-service, which means that users of that infrastructure, software as a service, platform as a service, infrastructure as a service, can get what they need on demand. So as a developer, if I need a test environment in the cloud, I should be able to self-service that. I should not have to raise a ticket in ServiceNow or send an email. If you're doing that, it's not a cloud. That means, by the way, that lots of people that say they've got a cloud don't have a cloud. This is one of my pet peeves. You know, we've spent all this money on implementing a cloud, but for developers, the outcomes are completely unchanged. I still have to raise a ticket and wait 2 weeks to get a test environment. Well, guess what? You don't have a cloud if it doesn't actually change the way that you get your job done, and you can't actually do better at your work. Second, broad network access. I should be able to access those resources on any devices I want, not just corporate laptops, but whatever devices I need to use to get my job done. Resource pooling. There is not a one-to-one mapping between physical and virtual devices. We have multiple virtual resources on a smaller number of physical resources. That's virtualization. That's what allows us to achieve cost savings, because hopefully our resources aren't 100% utilized. Rapid elasticity. This means I can scale up and scale down on demand. I have the illusion of infinite resources available to me. And then finally, measured service. I only use what I pay for. So out of all the people who said they were doing cloud, only 29% of people actually met these 5 characteristics. So that should not be surprising if you've listened to what I've just said, and you're probably like, oh, maybe we don't actually have a cloud. Only 29% of people who said they had a cloud met those 5 characteristics set out by NIST. But they were 24 times more likely to be in the elite performing group. So it's hugely important. Cloud really matters, but only if you do it right. It's a huge force multiplier. Another thing that impacts both software delivery and operational performance and productivity is code maintainability. What is code maintainability? Well, this is based on research that was done inside Google. And what they found is what you want is system and tools that make it easy, to change code maintained by other teams. So I should easily be able to create a pull request or a change request against some other team's code if I need to. It should be easy for me to find code in the code base from any team. I should be able to easily reuse other people's code. And then finally, I should be able to add, upgrade, and migrate to dependencies without breaking things. So if I need to upgrade some library, that should be straightforward for me to do. It shouldn't result in everything breaking. So code maintainability impacts continuous delivery. It makes it easier to do continuous delivery, and hence it also improves software delivery performance. It also improves productivity. So I'm going to switch gears now and talk about that second research model. How do we improve productivity? This is something we looked at newly for the first time this year. Of course, the first question you've got is, what do we mean by productivity? Well, this is what we mean. It's the ability to get complex, time-consuming tasks completed with minimal distractions and interruptions. So this is a psychological state. It means you feel like you can get stuff done without being distracted or interrupted the whole time. And this, crucially, is a personal thing. Most of the research we do is based on teams. The team is the unit of getting stuff done, of high or low performance. In this case, productivity, we're looking at individuals and how effectively they feel they can get their work done without being distracted or interrupted. It turns out, our research shows that higher productivity reduces burnout. When you feel productive, what you're able to do is leave your work at work and go home and switch gears and not think about it and have a better work-life balance. That in turn reduces feelings of burnout. So that ability to leave your work at work and then not think about it when you're outside of work, we call work recovery. That in turn reduces burnout. And as you saw in our other model, you can also reduce burnout by implementing continuous delivery practices, technical practices, and that ability to know what your change process is and get stuff done. How do you improve productivity? Well, firstly, having tools that actually are easy to use and make it easy to get your work done. And then search, we talked about the ability to find the information you need to get your job done, both within the company and outside the company. Culture is really important, as we'll talk about in just a minute. And then finally, reducing technical debt. And we'll talk about what that means in just a minute, but what we found is that reducing technical debt improves productivity, and you can reduce technical debt through code maintainability, which was that thing we talked about just a few slides ago. Having a loosely coupled architecture, which also, by the way, improves your ability to do continuous delivery, and effective monitoring. So again, we defined technical debt based on a model that's used within Google. Reduced technical debt means you don't have these things on the right. When these are the signs of technical debt. Firstly, when known bugs go unfixed in favor of new features, when there's insufficient test coverage, when you have problems related to low code quality or poor design, when code or artifacts aren't cleaned up, when they're no longer needed, when you have implementations that the team doesn't know how to debug and maintain because they're not familiar with the technology, when you have incomplete migrations, obsolete technology, or your documentation isn't up to date. We can reduce that technical debt by creating maintainable code bases through loosely coupled architecture and by monitoring. And these things together help us maintain a mental model of our systems, as Ward Cunningham suggested in his original foundational article on technical debt. So I just want to conclude by talking about culture. We talked about culture a few times here. We've actually studied culture for the last 6 years that we've been doing the State of DevOps Report. This year, specifically, we used a model that was developed inside Google. So Google wanted to know how to build high-performing teams, and they thought it would be, hire Stanford graduates, fire the management, and so forth. What they found is that it wasn't about technical skill. It was all about cultural things. They found the biggest contributor to building high-performing teams was psychological safety. Team members felt safe to take risks and be vulnerable in front of each other. You can't innovate if you can't take risks. And taking risks means that you're going to fail a bunch of times. And if that's not a safe thing to do, teams won't take risks and they won't innovate. Dependability basically means you can trust people to do what they say they're going to do. Structure and clarity means that everyone has well-defined roles, plans, and goals. And then finally, your work has to have meaning, and you have to have a feeling that your work is meaningful and that you can have an impact. So culture is important because our research shows it positively impacts software delivery performance, organizational performance, and productivity. You can change culture by implementing those capabilities that we talked about earlier. You change culture by changing the way you work, by implementing technical practices, by implementing a clear change process. And there's lots of other things that you can do to improve culture we've talked about in previous reports as well. So just to conclude, yes, DevOps is a thing. It has a measurable impact on organizational performance. There's measurable capabilities. There's lots of data on the capabilities that we talk about at cloud.google.com/DevOps. There's all those capabilities. There's whole pages on how to do them. We've talked about how to measure your performance, how to get better at it, how to measure productivity, how to get better at productivity, and the impacts of culture. And there is so much more in the report this year that we don't have time to talk about. You can go and download it at cloud.google.com/DevOps. All right, so I'm going to hand it over to you, Ben.
Oh, this was great, Jez, and I'd say I'm one of those people that actually print things out, and I printed out the report, and people started getting frustrated with me because there were so many pages. It's very deep and detailed, and you guys did a great job. Now, one thing I'd say before we get into stuff, please guys, go down to your Q&A, the functionality down there, ask questions. I'm also looking at some questions you guys asked before, so we'd love to hear from you. So Jez, you've been doing this for a while. You've seen a lot at this point. What most surprised you from this year's report?
I come from an ops background, and I've done a bunch of ops the last few years. What surprised me, like every year, I'm really worried that the data won't turn out to actually be statistically valid. And particularly that thing I talked about at the beginning, speed and stability, the cluster analysis that shows that high performers do better at both speed and stability. I always worry about that. Is that actually going to turn out? And this year we actually tweaked that a bit because it wasn't clear in the questions previously that deployment frequency was talking about deployments of production. So we actually tweaked that to clarify that. And I'm like, this year, maybe it's not going to come out. It came out, yay. And it predicts organizational performance. All the things that we know turned out to work. There was a few interesting little nuggets, like this year what we found is that test automation predicts continuous integration, which predicts continuous delivery. So that's something that's new this year. We found that actually test automation is useful because it helps you do continuous integration. So little nuggets like that were interesting. The productivity research model is entirely new. That I thought was fascinating. That was all driven actually by a lot of the research that Dr. Nicole Forsgren, the principal researcher, has done in the past. So that's all really interesting stuff. But apart from the interesting stuff, I'm just always really happy when the things actually fall out the right way, because that cannot happen. And this year it did.
Oh, that makes a lot of sense. And one thing you said there in particular, when you kind of do have that ops background, what are you guys still seeing as some of the barriers that guys that have been in traditional, teams that have been in traditional IT ops, struggle with making the transition to DevOps? I mean, you think that's changing? Is it still mostly cultural? I mean, what have you guys seen?
So I think that's a great question. And our research doesn't really focus on that in particular, but from my anecdata, I think what we're seeing is that actually, ops people have actually seen a lot of change. I think the main thing that I see in ops is that it's so, we're making it up as we go along. There's no ops degrees. It's still something that you learn kind of on the job. And so we've got a completely new paradigm of working here. Ops completely changes from data center to cloud. We're seeing completely new paradigms of security to cope with, cloud native software. We're completely changing the paradigm of ops. So there's whole new ways of implementing security controls. And we are having to make it up as we go along because these models are new and we're developing them. So I think that's the main thing. I mean, software development has changed some with the introduction of like containerization and so forth. But fundamentally, in many ways, you're still doing your job the same way. Ops is completely changing, and it's not, we're not getting taught the new way of doing it in school or anything like that. We're kind of making it up as we go along. So I think that's the hardest barrier. What do you think?
No, I think you're right on. I think it's still like there's I was actually just talking to someone the other day. It can be overwhelming, the rate of change right now. There's so much going on, so many changes. We were talking in particular like new platforms like containerization and stuff like that. And it's not like it was when I started out. We had a couple of years to absorb things. You have a couple months, at best. So I think it's hard, but it's also really exciting. And one thing that you said too, it was actually one of the questions, and I've always found this interesting. Particularly now that you guys are at part of Google. Are you seeing any? What kind of things have you seen around some of these kind of subgroups of DevOps? Let's call it that. Like because one of the questions was the difference between DevOps and site reliability engineering. Is that an important distinction from what you guys are saying in terms of this? Is that really just it's like, well, this is what we call ourselves and what our background is? I mean, what have you seen? Yeah,
well, site reliability engineering is a particular way of doing ops that was developed at Google. And it basically focuses on a few different things. I mean, there's a couple of books that Google put out through O'Reilly on SRE and what it is. But what it focuses on is treating ops as an engineering discipline fundamentally, and not as one where you're kind of manually intervening all the time, but where you solve problems through engineering approaches, and where we deliberately limit the amount of toil or kind of manual intervention you have to do in order to make space for actually improvement through engineering practices. It means that you have a special team of people called SREs who are in charge of running services. So it's a particular way of doing things. So people at Google have often talked about SRE as an implementation of DevOps that's specific to Google, but has certainly been adopted by many other companies. And it's certainly generally applicable. But you can kind of contrast it, for example, with the kind of Amazon approach, you build it, you run it, where you have teams that run cross-functionally for the entire life cycle of the service. It's a bit different from that. And the focus on toil and measuring things like error budgets and service level objectives. These are particular practices that are very specific to the SRE model, but can be more broadly adopted.
Yeah, no, that makes a lot of sense. And there was another question that that came up about federated DevOps, and I think that's really related to what you were just saying. Because like, have you guys seen any sort of data in your anecdotal experience about the differences between kind of a distributed DevOps model versus a federated DevOps model? Are there any trends?
Well, so I have not heard these terms before.
So in terms of like, I think what the question is trying to say, and is I've heard this as well, is like the difference between having a kind of unified team that acts as a shared service, like a shared DevOps team that provides DevOps services, versus like, I think what you're kind of saying with the Amazon model, where there's an embedded responsibility within the dev teams.
Yeah. So I think realistically, that division is not as strong as, it's not a binary distinction. I think one of the things in DevOps is that developers have to have responsibility for operational outcomes. That's key to any model of DevOps. So this idea where we're going to throw it over the wall and a federated team is responsible for the operational performance of my system and I don't have to care about it, that happens nowhere. So a key piece of this is, developers have to be responsible ultimately for operational outcomes. In the Google model, for example, the development teams have to run the service in production for at least 6 months, and then they have to pass a handover readiness review before it gets handed over to SRE, and then it gets handed straight back if there's a problem. So there's no world in which developers aren't responsible for operational outcomes if you're doing DevOps. I think what you do see that's a bit different is, for example, you have DevOps teams who build these kind of tools we talked about. So we talked about code maintainability, the ability to make changes to other teams' codes, to find that code and search it easily. That requires tool chains. And at Google, there's a whole team of people who's responsible for developer productivity and building development tools so that it's really easy to search code internally, so that you can make change requests to other teams' codes. You can basically change pretty much anything at Google. You know, I can go in and make a change request to like how Google front end works at Google, because there's a tool chain that enables me to see that stuff and do pull requests, which is really amazing. So there's teams responsible for that. There's teams responsible for the deployment team, for the deployment tools. There's teams responsible for monitoring and observability tools and making those tools available for everyone in Google. So that's the kind of thing that I see shared teams doing. They're not taking responsibility for the operational outcomes. They are building tool chains and platforms that make it much, much easier for developers to do that and get the feedback they need and make the changes they need.
Yeah, no, that's super interesting. You know, one thing a little related to that, to someone had asked, is about technology and tools. So, you know, I do remember like early DevOps, you know, days. It was like everybody was arguing about puppet versus chef. You know, we weren't talking about culture. We were talking about puppet versus chef. But I think it's a more mature discussion now. But do you see, you talked about cloud, and that was really great. I love the way you guys approach that. But also, do you see other technology trends that are affecting how people, you know, adopt DevOps, you know, beyond just cloud itself? I mean, are things like microservices and container adoption, you know, part of that, or what are you seeing?
Yeah, I think they can be. One thing that I'm really careful to emphasize, which was borne out in the research we did for the last couple of years and in previous years on architecture, is that, you know, those tools are great. You know, I work for Google. We spend a lot of time on Kubernetes. It's an amazingly powerful tool. It's neither a necessary nor sufficient way to ensure that you actually get better. So you can implement Kubernetes, and you can still have these very complex, big bang orchestrated deployments. In which case, what did that actually get you?
Right,
you know,
right.
So implementing the tool isn't enough, and you can do the stuff that we talk about with mainframes. You know, it's entirely possible to achieve DevOps excellence with mainframe technologies. So, you know, Kubernetes is great. We've seen teams being incredibly successful with it. It's amazingly powerful, but you've got to do it right. Just the same with cloud. You can't just pay for a cloud and not change your processes. It doesn't then you haven't achieved anything. So tools are great. We love them. They can be very powerful, but unless you actually do the work of doing process improvement and changing your architecture in order to take advantage of them, that, you know, it's not a silver bullet.
Yeah, no, absolutely. You know, there were a couple of questions around this, and I honestly can't remember. You know, basically, did you guys cover any kind of security integration into DevOps as part of the report, or was that?
Yeah, not this year, but we did do that last year. We spent a bunch. If you download the 2018 report and the 2017 report, there's a whole bunch of stuff we did on integrating security, and we do find it makes a difference. So when you integrate security testing into the development lifecycle, and you make it easy for developers to get that feedback, when you make it easy for developers to consume safe, known good versions of libraries, when you do scanning as part of your deployment pipeline, when you basically shift left on security and build it into the development process, we know that impacts software delivery performance. So yeah, absolutely, we find that's important.
Yeah, that's great. Yeah, I do remember that from last year. Now, there was one question about diversity here, and I do remember from reading the report, you guys did have some data in there about you know, diversity and changes there. So what were some of the things that you guys saw? Were there any big changes in terms of like what you were seeing? And
yeah, what we find in gender this year, we're looking at teams that have women on them, and it's really quite shocking. Only 16% of teams include women, which was a dip from the 25% of teams that include women last year. So I mean, that's really a huge problem. I can't overemphasize the extent to which that's a problem. You know, apart from the fact that these jobs, you know, there's an equity issue, right? Which is that these jobs are highly paid and they give you flexibility, so it's inequitable that women don't have these jobs or have access to them or are excluded. But it's also a huge problem because, you know, everyone's heard of the fact, oh, we're trying to hire DevOps people, SRE people. Well, if your industry is excluding 50% of your target audience, that's a massive problem. So, I mean, that's a real opportunity to get better. And I think the fact that there isn't a clear career path into ops is part of the problem. And I think as an industry, we have to get much better, helping people enter the industry. You know, realistically, you can't say these are the necessary skills to succeed at DevOps because we're all making it up as we go along. That should be an opportunity, but it's being used as a way to exclude people. So we need to change that. And then we also need to find ways to improve inclusiveness. You know, if you've ever worked on an all-male team, you know, I know women who've come into that environment and you know, found it a bit unpleasant to work in. So I think we've all got to be also conscious of how we behave and what we say and how we talk and make our industry more inclusive so that the women who are in it don't just leave because it's so unpleasant.
Yeah, no, I think that's you're absolutely right. Well, I think we've gone through a lot of really good questions here. Before we kind of close it off with a couple other things, anything you want to leave the audience here with, kind of the walk away with?
Yeah, I think the thing is, the things to remember is this probably seems quite overwhelming. The good news is you can do this incrementally, bit by bit, and that is the best way to do it. Pick off something. Find ways to experiment with trying new ways to implement new ideas. Set yourselves clear goals and do this incrementally. You can't achieve sustainable change in a big bang project-based way. The way you do it is by giving teams capacity and resources to experiment with new ways of working and working in small batches so that you can try things out, see what works and what doesn't, and learn quickly, and then take the things that work and build them in. So use DevOps techniques to implement DevOps, do it incrementally, but crucially, it does matter. So this stuff works. We know it works, even in large, highly regulated organizations. You can't just copy what other people have done. Every organization is different, but you can be inspired by what other people have done and use that to try things out for yourself. So think about which of these things you think is interesting. Think about what little thing you can do tomorrow to start experimenting with that, I would say.
No, I think that's really great, and I think that's one of the things I've enjoyed about your guys' report that you've been doing for the last few years is that you do make the point that it's accessible, that anyone can do DevOps if they're willing to invest and make those changes. So I think that's really great. Well, let's we'll have a couple more things to kind of close out here, and then for those of you who didn't ask your burning questions, you can always follow up with us later, and we can reach out to Jez if there's specific things for him. But I, of course, appreciate everybody coming on. A couple of things I just wanted to close out with. One of the reasons why we really enjoy working with Jez and Dr. Forrest Grant and the rest of the team is that they're a data backed group. They really want to get the right data and get to the right answers based on that, and that's something that we really believe in at Sumo Logic. And so one of the things too is we actually just released our own report that was based on what our customers are doing in the cloud. I think if you're interested in what Jez and team have done with this report, I think you'll be interested in our new continuous intelligence report. And it's basically, we went to our 2,000 plus customers, looked at how they're adopting cloud. So you can see that this, a lot of what we see is about how people are adopting cloud and what they're doing in the cloud. It's the 4th year we've done it. You can find it at the URL there at /brief/continuous intelligence report. I recommend you guys check it out. I think you would enjoy looking at it. And just to give you a sample of the kind of technology adoptions, one of my favorite stats is we have, and I'm going to talk about this in a second, we've been doing a lot with Kubernetes here. It's something that our customers have been experimenting with, and we've been supporting them on that. And one of the things we looked at was Kubernetes adoption. So in the report we have about database adoption, different technology adoptions, about how people are, how much they're moving into the cloud versus on-premise. But, for example, here, we thought we'd check to see if Kubernetes adoption was correlated at all with what cloud environment they were in. And so what we saw, and you can kind of see here, is that there's a correlation with being in the cloud, obviously, particularly with Google, as you would expect. But if you, what you're also seeing is that there's a big correlation between being across multiple cloud environments. So, for example, that was surprising. That was something interesting, that people are using Kubernetes as a way to basically spread out across multiple different environments. And so that there's a lot of different cool types of stats in there that you'll be able to take a look at. I recommend you go check that out. Now, another piece that you might find really interesting is our Kubernetes ebook. So we spent a lot of time trying to make this a really useful, interesting ebook. It is basically my one goal for this was to not choose something that you just pick up and say, not want to read. I wanted to make something that was, our team wanted to make something that was really valuable and actually, provided practitioner level type of best practices. So it's 30 plus pages of goodness about all the way from what you should, how you can approach Kubernetes, the kind of things you should look out for, and also, how we can help you implement that. So I definitely recommend you go check that out, at /brief/Kubernetes observability. And one of the reasons why we made that ebook is that we just finished our user conference last week, and it was great. We had a lot of great customer sessions, which will actually be available some point soon. If you want to go check that out. But one of the things we announced was our new Kubernetes solution. So, as part of our platform, we announced a new integration with Kubernetes. And one of the things we did is we really embraced the community that functionally Google built, that Google in the Cloud Native Computing Foundation, and just embraced that community, because we think it's really important to be part of that community and support that community. And what we did is we did direct integrations with the open source community, use those open source platforms and tools to enrich the data that's coming out of Kubernetes. So you get all that rich context, which is so important to be able to troubleshoot your apps using the deployment tools that are a part of the Kubernetes community, and then pulling that all into Sumo Logic so you can have one clear place to go to see all the data that you need to see to look at Kubernetes. And so there's really three pillars that we talked about, and you guys can go on our website and find out more about this if you're interested. Actually, check it out. There's a great demo on there. But just really quickly, one of the things was discoverability. So, an important part of DevOps overall, but in particular with Kubernetes, where it can be so complicated, like Jez was referring to, is being able to quickly trace customer issues to platform issues. It doesn't matter what platform you're using or what you're deciding to do. If you can actually figure out if an infrastructure issue that you're seeing or an application issue you're seeing is actually affecting your end users, that's why DevOps was created in the first place, was to essentially create a better experience for both the people that are using your application and for the people creating that application. So to be able to do that, you need to be able to tie those points together. And the way that we did that was by using the great mental model that was used with Kubernetes that kind of came out of Google, and this kind of service namespace cluster pod and container model. And we built that into a dynamic structure that you see on the left there. And that way you can choose which way you want to approach your problem and be able to go from a service level customer view all the way down to the container view. Now, the way that we enable that is what I just talked about, where you can actually get all that data, logs, metrics, system and security events, and then tie that together and correlate that data so you can make decisions faster. And finally, one of the things we thought was really important, and it was something that Jez and I just talked about, is that you want to have a security view in here. The reality of the state of how you manage modern applications at scale is you can't leave security out, and you don't want to be putting your key important customer data in a platform that you're not sure what is happening from a security perspective. So what we did is we, again, embraced the open source community, what was out there, and that was Falco, which is a kind of a security event analysis tool, and we were able to integrate that out of the box with our with the integration that we have, and you can bring that data in and see it together. So again, this is an important part if you really want to integrate security into your DevOps process, you need to have visibility in the first place. And the way you do that is through something like this. So this means that, through those same dashboards we were just showing a second ago, you'll be able to get this full visibility. So, definitely go check this out. This is something we've got demos up right now where you can sign up for a 30-day trial, try this out, get your Kubernetes data in there. And we also obviously integrate with all the major platforms, in particular Google Cloud. We actually just announced some more integrations with Google Cloud last week. So go check that out and see how we can, help you get to where you want to be in terms of your operational security readiness. So, with that, I thank everybody for joining. I hope you really enjoyed this, and it was really really good to have Jez on here. And Jez, I appreciate you taking the time to come on with us.
Thanks very much for having me, and thanks so much for sponsoring the report. We really appreciate it.
Absolutely. We'd love to do it. And thanks everybody for joining, and we'll be following up with other details later. So have a great rest of the day.